Good morning, class. So today we are going to talk about inverse functions, right? Now, what are inverse functions? They are, well, we've already seen them, but we've never actually talked about them. We've never actually solved some of them. And it's important that we do. If you remember, when we were talking about exponential functions, such as f of x is equal to any number, let's say c to the power of x, we said that the graph had to have a one-to-one correspondence and an inverse function, but we never really talked more about that. So today we're going to talk more about what inverse functions are and why they are important. So we've all basically an inverse function is, let's say we have f of x is equal to the square root of x. Well, the inverse function is what do we have to do in order to get the inverse. I don't know how else to say it. So in this case, many of you may have guessed it will be f of x is equal to x squared, right? Because whenever we have the square root of x, the inverse, or let's say the opposite operation, would be squaring it. Okay? Now, here's where it gets tricky. Even though it works from square root to x squared, if we have f of x is equal to x squared, this actually does not have an inverse operation. Okay? In order for it to be an inverse operation, we must follow these steps right here. Let's see if it can focus. There we go. All right, so number one, it has to be only a one-to-one function. Okay? One-to-one. Do you guys remember what that means? It basically means that whenever we have our domain and range, let's say we have x, y, we only have one-to-one correspondence. So if this is 5, this needs to be, let's say, 3, and then 2, 0, -1, -5, or something. The numbers don't repeat. That's what it means. Okay, to have a one-to-one correspondence. And you might be thinking, but then what does that have to do with x squared? Well, if you remember, with x squared, it would look something like this. Let's do it a bit more professional with f of x. Whenever x is -1, f of x would be 1. But when x is +1, f of x is also 1. Okay, so we have two values that yield the same result, two inputs that yield the same output. And that is not allowed whenever we're talking about inverse functions. Okay, so our the square root, if we have, let's do it cleanly here. If our original function is the square root of x, then its inverse function, this is the notation, I was recording blank paper, awesome. So the inverse, that's the notation, el negativo, no? The inverse function of x would be equal to x squared. And how do we find that? How do we find that this is the inverse function? That's what I'm going to show you right now. So let's say, you know what, let's go straight to the example. No more dilly-dallying. Let's say we have f of x is equal to, let's say a number, 10 to the power of x. Okay, so we already know that if we have the square root, we just square it and we have the opposite. But what is the opposite function of 10 to the power of x? How do we find that value of x? How do we solve for it? Well, in order to find it, we have to follow these steps. First of all, we take f of x and we change it to y. So y is equal to 10 to the power of x. Then, after we have done that, we shift, let's say, the values of x and y. So x comes over here and y comes over here. Notice that we can only do this, once, as I stated before, if we have a one-to-one correspondence. We haven't talked about it, but in this case, it does follow that trend. It is a one-to-one correspondence, right? So now how do we find now we have to solve for y. And if we notice, there is absolutely no way, at least that we know so far, for us to solve for y. That is how we usually find the inverse functions. We change the y with the x, and then we solve for the y once again. But we're stuck here. There's nothing we can do with our current knowledge. And here comes our savior. Logarithms, and I missed an M. So a logarithmic function is the inverse function of our exponential function. And how does it work? Well, it would look something like this. The logarithm base 10 of x is equal to y. So we go from here all the way up to here. This is my inverse function. Okay, I know it's not as clear, but don't worry. Hopefully with our example it will be. And this is what we're going to talk about for the rest or in the next video. Okay, I'm gonna split this in 2 videos so that I have enough time, because I think it's gonna be kind of a long video today. Alright, so logarithms. The logarithm base 10 of x is equal to y. Okay, see you soon.